Hello. Today I will briefly discuss the various elements in a flyback circuit. Let's get started. So let's demystify what a flyback controller is. Because the flyback topology uses a step-down transformer, it is typically an isolated power stage. The primary side of the flyback circuit is high voltage and is unsafe to touch as you would experience a nasty shock. The secondary side is normally a much lower voltage and considered to be safe to touch. So let's have a look at the different parts of this circuit. First, there is the AC rectification stage with the diode bridge we discussed earlier. The high voltage startup is required so that the flyback controller IC can get power to start switching. Auxiliary power is how the flyback controller is powered more efficiently. This is taking advantage of an auxiliary winding on the primary side of the transformer to self-power while operating. In order to regulate the output voltage, there has to be some feedback. This example is showing primary side regulation, or PSR. More on this later. The transformer is an efficient way to step down the high voltage on the primary side down to a lower voltage on the secondary side. This is based on the turns ratio, which you will see as NP to NS. Then there is the power switch, which traditional is a silicon FET, but depending on the application needs, the design may choose silicon carbide or a GaN FET. A shunt resistor is used to limit the current ramping in the primary side of the transformer. The reason a clamp is required is to limit the stress on the power switch, when the power switch is on current ramps in the primary side of the transformer. When the switch is off, the current has to ramp down and the voltage would continue to build across the power switch. The clamp shunts this energy back to the source. Last but not least is the output rectification. This blocks current from discharging the output when the primary side is ramping. I hope you found this informative. To see more, please like and subscribe